The same period, many players within the region and outside, after seeing the potential of RCMRD and what can be, what benefits we can get from the activities and issues and our mandate, many have come up to partner with RCMRD to undertake the different activities that you'll see and will have led to issues like GMS that I'll come to later. Now, along the way, RCMRD has been able to partner with other global players like the EU, USAID, African Union, GIZ, NASA of the US, and different governments within the member states, both at national, regional, and local level, as the case may be. And from that point on, we've been able to handle diverse projects, some with a regional look, some national, and some with an international outlook. You'll find that we have projects like AGRA, we have the Severe project, the GMS project, and several others that we are handling with AU, NEPAD, a project like NELGA with AU, LPAD, and several projects within the member states and the other countries outside our member states. Now, specifically to come into GMS, that's a brief overview of RCMRD. And the colleagues, I want to re-emphasize that this organization belongs to the member states. It belongs to you. So feel part of RCMRD by doing everything possible. Visit us on our social media outlets and get to know further about RCMRD. Feel free to contribute or make inquiries that we shall promptly respond to, but also encourage you to be party to the activities of RCMRD. For example, every year we hold a conference similar to this one in the month of August. It's called the RCMRD International Conference, where we showcase advances in research and development. And I want to thank Makerere University, particularly the department we are in now of Geomatics and Land Management, for being a major player in our conferences. And for that matter, we had also to be part to this, as we are strong partners in the same field that we are serving. So colleagues, ladies and gentlemen, I encourage you to take part in RCMRD activities. The benefits are immense and the networks are so far and wide. Now, GMS. What is GMS? GMS and Africa is an acronym for Global Monitoring for Environment and Security. It's a program under the AU, African Union Commission, and is specifically being led under the African Space Policy Strategy. The programs of GMS are co-funded in partnership with the EU. Now, what is happening is the vision of AU 2063, and among the things that are entrenched therein is the need to push for a space policy in Africa, and to ensure that we leverage the very diverse benefits of space science in Africa. The GMS is a successor, and it builds on earlier projects that have been run under the AU Commission. Those were a project at AMST and MESA. And the 5 major outputs for GMS project include: 1, access to Earth observation and data maintenance. The idea is that we want to see that there is increased access to Earth observation by all member states of the AU, and to be able to manipulate the data and put it to use for the persons that we serve in the continent of Africa and beyond. The other output is to help in the area of natural resources and natural and water resources services. Colleagues, as you would all appreciate, this is one area, if not handled well, I don't need to re-emphasize the dangers that we're already seeing and what the future looks for us as a continent and humanity if we do not appropriately or instantly handle the issue of natural and water resource management. The other output for the GMS project is marine and coastal service. Now, we all know that for some reason, because many of us are not coastal nations, we've not helped others who are in the coast, or we forget that we depend on the coastal nations in many, many different ways. And for them to survive sustainably, we have to support each other in the marine and coastal services to ensure sustainable development and management. But that aside, even us who are landlocked have marine issues to handle. We have our lakes, we have the rivers. I know that colleagues here are handling different projects in the Lake Victoria and others. So the GMS service supports this kind of activity. One of the other core outputs is education and training. And I wish to report that GMS project and AGRC2021 has been carrying out a lot of training activities within the member states. And we've now moved to postgraduate training, and I know part of the projects today, the coordinator, Professor Girudu, is going to present to us, Sir Chairman, the coordinator is going to present to us some students who have been running a Master of Science program from the different project countries, Kenya, Uganda, Ethiopia, and others. Is going to present to you some candidates. If you are here, please raise up your hands, the MSc students. 1, 2, 3, 4, 5, 6, 7, 8. I think we have 8 here, or it should be more. Professor Girudu is going to present to you, Mr. Chairman. I think they have either successfully or around there completed their studies. But this is part of what GMS project has been financing and promoting within the project countries. I know Professor will mention that this is a continuous project, and we should encourage our youngsters within our member states and the GMS project areas to grab this opportunity as it lasts. And other activities are outreach and raising awareness. We've been, as AGRC2021, together with our sister organizations in the consortium working on awareness on the masses, and we have agreed that we target the leadership at the different levels, local leaders, and national leadership, including members of parliament in different countries, and plus cabinet where possible. I mentioned that the project countries include Uganda, Kenya, Rwanda, Djibouti, Ethiopia, Mauritius, Eritrea, Somalia, Sudan, and South Sudan. And the programs have been running concurrently in the different countries. We've had a few challenges in some countries because of unavoidable situations, but by and large, the GMS program has been a success in the different countries where we have footage. Under GMS and Africa projects, in the Eastern Africa area, RCMRD has been at the lead of a consortium of different players, including the Geospatial Information Institute of Ethiopia, the Rwanda Water Resource Board, the Department of Surveys and Remote Sensing of Kenya, the Resource Survey and Remote Sensing of Kenya, the Ministry of Urban Development and Land in Mauritius, Benadir University in Somalia, the Ministry of Environment of Djibouti, the Ministry of Environment in the Republic of the Sudan, the National Bureau of Statistics of Southern Sudan, and of course, the one and only Makerere University of Uganda. The thematic areas where RCMRD has been taking lead, ladies and gentlemen, include land degradation monitoring and assessment, wetland monitoring and assessment, and the open regional reference vector database for water and ecological zones. Now, colleagues, allow me to speak about the few achievements, few but major achievements that have been made in this region and over this period. Under land degradation monitoring assessment, players led by RCMRD have been able to develop land degradation maps for the many countries in the IGAD region. Now, these maps have helped us to indicate the hotspot areas for intervention planning and decision making. Out of this, someone can be able to look at the input and the influence of topographic factors, and some weather information can be deducted from these maps. Under the wetland monitoring and assessment, we've continuously been doing wetland profiling, which can be used by scientists, decision makers, researchers, and other players to indicate and point out the benefits and the potential of the wetland resource. Under the regional vector database development, we have been able to promote access and awareness of data on water and agroeconomic ecological zones within the regions and the GMS project areas. Over this period, we have also launched the RCMRD GMS and Africa Geoportal to promote access to various products within the thematic areas that I had mentioned earlier. I encourage you, colleagues, to take time and visit the Geoportal for RCMRD GMS and Africa. You feel free to contribute in any way or make comments that will be of good development, good and important development and management of resources within our region, Africa, and definitely we are part and parcel of the universal climate question. And we've had open days to just sensitize the public about, sensitize the public and create awareness about GMS and Africa. And these open days have been held in Kampala, in Addis Ababa, and in Djibouti DCC. We think we should have, before the year closes, another open day in Mauritius and another country as we plan along the way. As I mentioned, we have, together with the different universities, had students taking MSc, and I think, Mr. Chairman, on your program, they'll be coming to give us a few products of their research for the benefit of the community here and online. Mr. Chairman, I thank you so much. That's what I heard from GMS and Africa and RCMRD. Thank you so much for the organization, Makerere University. Thank you, participants, both here physically and online, for listening to me. Thank you.
Thank you very much, Paul, for your presentation of RCMRD and GMS and Africa. I don't know if we are to take the questions now or if we wait at the very end. But if you have any question, in any case, I think we can take it on and he answers it before we bring in other presenters for the day. Thank you. It seems we do not have any physical question. Do we have any questions from online? Well, it seems we don't have any questions. Thank you very much, Paul. Thank you very much for your presentation. So next is a presentation by students that have been supported by RCMRD, GMS and Africa. And we have a number of presentations. There are around, I think, 8 of them. And so I think more than anything else, really, I'll be more of a timekeeper. The time that is scheduled for each presentation is 15 minutes. So, and that 15 should be, you do the presentations, we do the questioning, and then we move on to the next presenter. Thank you. So the next presenter is Ms. Christine Atuire, and she'll be looking at exploring the use of satellite imagery in monitoring air quality in Kampala. And specifically, she's looking at PM 2.5.
Good afternoon, everyone. My name is Christine Atire, and I'm going to be sharing the work that is still in progress but almost completing. It's looking at exploring the use of satellite imagery in monitoring air pollution, and specifically, we are looking at the pollutant called PM2.5. So, air pollution has become a major threat in almost all cities and urban areas around the globe, and Kampala city or Kampala district has not been spared either. So particularly the research is looking at PM2.5, which is a pollutant, and this means particulate matter with diameter less than 2.5 micrometers. So various research studies have identified it as one of the leading pollutants because these particles are very small, it is highly inhalable, so it has been linked to various respiratory diseases, and this has raised the attention of various researchers and the public to monitor the concentrations in the atmosphere. So one of the strategies that has been put up to monitor these concentrations is through establishment of monitoring stations, and specifically in Kampala, this is being done by Kampala Capital Authority, CCA, and then AGRC, which is a university-based setup here in Makerere. So KCCA has around 25 monitoring stations in Kampala, while AGRC has around 25 stations. So this is a good initiative, but however, it has come up with still some challenges that need to be addressed. One of them being that what we can get from these stations are just point measurements, meaning that the measurements relate only areas where those stations are. And then secondly, when you look at the spatial distribution of these stations, most of them are located within the urban area, meaning that areas outside the city center, we cannot easily detect or know how much concentrations of PM2.5 are there. So this takes me what the research was looking on, or what it tends to address. So we are saying, much as we are getting accurate measurements from the ground stations, these stations are prone to vandalism. It can be by people or even extreme weather conditions. So what that brings about is data gaps. So that means we cannot adequately or continuously have measurements about PM2.5 concentrations in Kampala. So therefore, this research looked at how we can explore the use of remote sensing data to monitor particulate matter concentrations in Kampala, and as a way of supplementing the deficient ground monitoring stations that are available. So the main objective was to determine satellite-derived PM2.5, and then the specific ones, first one is to characterize variations in aerosol optical depth. Aerosol optical depth, those are the satellite aerosol measurements. And then secondly, correlate the satellite observations and ground observations to determine satellite-derived PM2.5. So the methodology that was used, mainly we are looking at Landsat and Sentinel-2 images, so that there are two sensors that were employed in this research. And then we are looking at meteorological data, because satellite observations are taken under the influence of weather conditions, so there is need to incorporate that. And then finally, the in situ measurements, which are PM2.5 measurements from the ground monitoring stations. So the first thing was to compute aerosol optical depth, which is the AOD, and this was done using the Christine algorithm. So from the AOD, our first objective was to characterize or understand these variations. However, we cannot understand these variations without putting into consideration of the meteorological data. So that's why our characterization of AOD was based on meteorological data. So we did the spatial characterization, which is identification of hotspot areas, the high and low concentrations. And then the second bit was on temporal characterization, and this we looked at how aerosol concentrations are varying in the different seasons. And then also we looked at how does the AOD measurement relate to meteorological data. So from that, we moved to the objective 2, which is determining satellite-derived PM 2.5. And in here, we are using a relationship between AOD and ground PM 2.5 to estimate the satellite-derived measurements. So to do that, we came up with 2 models. One of them was looking at the seasonal model, modeling the relationship seasonally, and in another model, looking at modeling this relationship as at each satellite overpass time, which we called the time-specific model. So the two models were evaluated, and then the best that best describes the relationship was used to estimate PM 2.5 from the satellite observations. So some of the results that we have. So like I said, the first thing was determining aerosol optical depth. To understand the aerosol optical depth, this has been grouped into the different seasons. So we have Sentinel and Landsat. Landsat, we have only one image because the images that could be available at that time, the ground observations were missing, so we could not use them into the analysis. And then the other thing was about cloud cover. So that's what reduced the satellite, the Landsat images. That's why we ended up with one. And also given that Sentinel temporal resolution is 5 days, it is easier to have many more images of Sentinel than Landsat 8. So what we can get from the distribution of aerosol temporary, we can see that within the wet season, the AOD values are higher compared to the wet season, because we can see within the dry season, the measurements are ranging around 0.4 to even greater than 0.7, which is high concentration. Whereas in the wet season, we are looking at most of the observations being between 0 and 0.4. So that one tells us already the seasonality within the AOD or the satellite observations. So to further do the characterization, now we look at how these observations relate to meteorological data. And for meteorological data, we are looking at wind speed, air pressure, temperature, and relative humidity. So the first thing that was done was to look at the linear relationship and also look at the nonlinear relationship, how they relate to each other. What is clear in both in the wet and the dry season is that the linear relationship between AOD and meteorological data is very weak. So that means that the variations within satellite observations are complex and cannot be modeled using simple linear regression equations. Whereas when you look at the nonlinear relationships, the relationship is strong, and this tells us the contribution that meteorological data has on the AOD variations. So when we look at the spatial component, the spatial variations, we want to see how these variations are changing from one place to another. And in here we did the hotspot analysis. So what we can observe from here is that also the hotspot areas are not constant. They are varying from one place to another as at each satellite overpass time. But what is clear or what is consistent is that most of these hotspot areas are occurring along transport routes and within the CBD. So that means that the activities along those areas contribute to the high aerosol concentrations. And this can further be explained from this slide. So an extract of one of the hotspot areas, those who are familiar with Kampala, this is around Kampala Mukono Highway near Spear Motors. So when you look at that area, there are a lot of activities that take place there. one of them being that we have a road junction, yes, the road that goes to Tuntinda, we have a containers depot, we have a factory, Pepsi company around the same area, and then we have a garage that is situated along the road. So all these areas, or all these locations contribute to the aerosol concentrations because there is a lot of emissions from the vehicles on the road, from the factory that is relocated there. So it explains why we have high aerosol concentrations within that area. So that is on the spatial variations of AOD. So moving further to estimate RPM 2.5 now, we said we are using two models, which is seasonal and then the time-specific model. So an evaluation was done on both models to determine which one best represents the relationship between satellite observations and ground observations. So from the evaluation, it can be seen that the time-specific model, which models the relationship between AOD and ground PM 2.5, is best explained when we look at it at each satellite over past time, not combining the entire season, let's say the wet season or the dry season, because we see when we look at each satellite over past time, the variables are able to explain the variations within PM 2.5 beta when we consider the time-specific model. So that is the model that was adopted to estimate PM 2.5 measurements. So as we can see from that, then of course we did the dividing of the data or subsetting into two parts, the testing and then the validation set. So using the validation set, we can see that the model performed moderately well because about more than 68% of the variations within PM 2.5 could be explained by meteorological data and then the satellite observations. So when we look further now from what we have estimated from satellite observations, we can see that as at that time when the satellite passed over Kampala, within the dry season, Kampala was experiencing unhealthy concentrations for sensitive groups and some bits of unhealthy for all. So meaning that the pollutant concentrations at that time were very high and very unhealthy. Whereas when we look at the wet season. When we look at the wet season, the concentrations were moderate and even good at some point. So this already takes us back to what we saw at satellite observations, explaining the seasonality within the observations, and it can be seen that even the ground observations that we have estimated from satellite observation also show us the seasonality within the concentrations. So to perform the validation of what we came about, we used the validation set, and this was not used within the testing data. And we used correlation between the estimated and the ground observations. So from the coefficients, we see that the R-squared values are ranging between 0.4 to even 0.9, which is moderate, meaning that the observations that were estimated or the satellite derived are representative of the ground measurements. However, as we can see that within the testing set, the observations that were used are different and they're actually low. And this was brought about by the issues that I already talked about, the missing data from the ground stations and the cloud cover within the sum of the images. So it is hard for us to rely on an R-squared of, let's say, 0.9 that is from 4 observations. So that's why we went further to use the root mean square value as an assessment of the performance of the model. So from the root mean square value, we can see that all our root mean square error values are below the minimum observed value at the ground stations. So that still tells us that the estimated PM 2.5 is still representative of the ground observations. So to still talk about the validation, yeah, we can see from this diagram that is the satellite derived, the mean, and then the in situ, PM2.5, the mean. So we can see there is not much variation. However, when we look at the Landsat 8 data that we have seen, we can see some big difference of underestimations. Yes, that is possible. However, at this stage, since we used one Landsat 8 image, we cannot conclusively say that Sentinel-2 performed better than Landsat 8 because the sample that we have is not big enough for us to make that conclusion. But nevertheless, still the performance can be compared. So, in conclusion, what we can say is that aerosol optical depth, which are the satellite observations, they are seasonal dependent and varies spatially, like we saw on the hotspot analysis maps. The hotspot areas were not constant, so it still varies spatially. And likewise, the relationship between AOD and meteorological data is not linear or is not direct, so we cannot explain it using linear regression analysis. And then, secondly, we can say that no single model can best describe the relationship between AOD and PM2.5. Like we saw that the model as at each satellite over past time was able to describe this relationship better than using a model that may be for the dry season or for the wet season. So that means the relationship has to be modeled as at each satellite over past time. And then lastly, the correlation between the satellite-derived PM2.5 and ground-based measurements still tells us that remote sensing data is capable of supplementing the deficient ground monitoring stations. Some of the recommendations that came up from the work is that for us to be able to use satellite data to monitor pollutant concentrations, we need to carry out operationalization of the model. So that means we need to put it in practice and see how we can incorporate satellite observations, ground measurements, and meteorological factors and all the other weather conditions to monitor our pollutant concentrations. And then secondly, that is future work that we recommend to be done on the operationalization. And then second recommendation is that, like we saw on the validation, the satellite observations or the satellite-derived PM2.5 highly depends on the amount of ground observations that we have. So for us to achieve objective one and be sure that what we are getting is right representative, we need to further densify the model. Yes, the initiative is good, they have done much, but there is still need room for improvement to densify the available network within Kampala. Yeah. Thank you very much.
Thank you very much, Christine. One question out of simply curiosity. From the hotspot map, is it possible to locate where downtown is?
Yes, it is possible to locate it, but it's around this place here.
I would imagine.
Yes, it's around there.
Great. So, to the audience, do we have any questions for Christine?
Thank you for the good study and the nice presentation. I was intrigued when you say that there is a startup that's involved in air quality monitoring, that AirCo company. What is the business model? How does it make money from monitoring air? Thank you. The company you mentioned, which helped you get some data, called AirCo. is a business company, right?
It's a research project that is going on within the.
Nothing. Okay. Great. Thank you, Christine, for your presentation. And thank you, GMS, for the sponsorship. Great. The next presenter is Ayele. He's not around. I was informed that he got a problem, right? Quite sad. Then the next is Faustin from University of Rwanda, and he'll be presenting characterization of a catchment erosion potential through hypsometric analysis. And he's looking at Yanze watershed in Rwanda.
Thank you, Mr. Chair, and thank you all for this opportunity to talk about my research. My name is Faustin Gashakamba, and I did this research as my thesis for the program of Master in Geoinformation Science at the very innovatively called University of Rwanda. In terms of background, we know that land degradation and soil pollution are some of the most pressing issues in terms of environmental protection and development in general. So soil erosion is one of the contributing factors to these two factors. In terms of water pollution, soil erosion contributes to siltation of water courses. But also in terms of land degradation, soil erosion is one of the factors of degrading fertility. And fertility in our agricultural societies, fertility is a big issue. So I wanted to look at this issue of soil erosion in a small watershed called Yanze. Because this Yanze watershed is located near Kigali City, and it's the main source of water supply for this city, but also is very inhabited, is densely inhabited, as any watershed near a big city would be. But there has been some initiatives before from different players, government projects, NGO players doing soil conservation projects in that watershed. And the results have been mixed. I mean, some projects were successful, depending on their objectives, some others weren't. And mostly, the problem is almost always lies with the budget. Because these soil conservation projects, they are very expensive. I'm saying Yanze is a small watershed, but still is a big area. So you need a lot of money. And sometimes it's all of the time, that money is not there. So that's why you need some kind of prioritization. Whenever there is a soil conservation project, you cannot apply the same measures everywhere. You need to prioritize some areas within your study, your area of interest. So I was looking and see, is there a way hypsometric analysis can help in terms of prioritization of soil conservation measures in a given area? So that's what my project set out to see, to know if we can use hypsometric analysis, some hypsometric metrics, to use them as a predictor of erosion in an area. But also some other objectives of the project was to look at how we can use GIS to conduct a morphometric analysis of watershed, and also develop a risk profile, an updated risk profile for this Yanzi watershed. We have erosion soil loss studies that have been conducted nationwide or a bigger region and a bigger scale. And the resolution of the studies were not good enough, fine enough to be used at the local level. So one of the objectives of the project was also to establish a soil risk profile for this watershed. The methodology, the study had 3 components, if I can say. Does it have a pointer? Oops. These are the, normally for those who are familiar with the revised universal soil erosion equation, there are some factors. Normally there are 6, but 2 are combined here, so we have 5. So the first one is called rainfall erosivity. Rainfall erosivity normally is calculated from rain intensity and energy data. It's called the hydrograph data. It's very detailed rain event data to say every minute the intensity of the rain was this, it evolved like this. You have this for every rainfall event for the whole year. So this kind of data doesn't exist anywhere in Africa, I could say. So for me, I used normally available data, daily rainfall data, and there are some empirical equations that were derived to calculate rainfall erosivity using such data. For this cover management factor, this is a way to express the role of vegetation in controlling rainfall intensity to cause erosion in an area. An area which is covered, heavily covered by vegetation, that vegetation will reduce the intensity of the raindrops to the soil. It also increases infiltration. So where there is a lot of vegetation, or the land cover is like forest or some more highly vegetated land cover type, then the cover management factor will be low. If there is any vegetation at all, then the cover management factor will be high. This one, called support practice factor, this is to express in the Russell equation, to express the kind of existing soil conservation measures. If the area is terraced, if there is mulching, what kind of agricultural system used. This one is captured here in the support practice factor. For this, we also had to use land cover maps, and there are some other factors which enters into this equation and to calculate this one. The land cover map was developed using Sentinel data imagery. So soil erodibility, this is to capture the susceptibility of soil to erosion. Normally, this is calculated from texture, soil texture data, what fraction of silt, what fraction of clay, what fraction of organic matter, sand, and so on. For this, well, we use soil attribute map, but we couldn't find local data, so we used data from Africa Soil Information Science. It's a global database established by ISRIC. And this slope length steepness factor or topography factor, it's used to capture the ruggedness of the terrain. So for this, we used a DM that's available, a 10-meter DM that's available in Rwanda. So this is the first component of the study to establish the soil profile, the soil erosion profile of the landscape. The second component was about hypsometric analysis of the area. Here we need the dam, of course, and then the hydrologic network that the data was available at the office in charge of water in Rwanda, and then we delineated the area into sub-watershed. In total, we delineated 93 sub-watershed, and for each sub-watershed, we calculated an hypsometric curve and also an hypsometric integral using different software, including R. Then the two maps, this one, the soil erosion risk map, and the hypsometric map were correlated to see if there is some correlation. So we conducted that correlation analysis, and that was the end of the study. That was the methodology. Now, some of the results. The first component about the hypsometric analysis of the watershed. So this is the watershed. This is the watershed. The area in dark green, the area where the hypsometric integral is high. The area in yellow, light green is where the hypsometric integral is low. So in general, for the whole 93 watershed, the lowest we could find, the lowest hypsometric integral was 0.5. The highest was 0.9. As you can see, all of the sub-watersheds were at equilibrium stage, but mostly were at young stage. Normally, equilibrium stage is between 0.4, 0.6. Beyond 0.6, it's the landscape is said to be at a young stage. Only below 0.4, that's where you can say the landscape is mature. So no sub-watersheds were found to be at a mature stage. That's what I can say. In terms of spatial distribution, general pattern you can see is that the downstream of the watershed is more it is more at a mature stage compared to the upstream stage. In terms of statistical distribution, here I put the lines to show which sub-watersheds are in the mature stage, in the equilibrium stage, in the young stage. As you can see, most of the sub-watersheds are in the young stage. Only a few are in the equilibrium stage. No sub-watershed was found to be in the mature stage. This is the mean of the hypsometric integrals. So you can see the mean is well in this young stage. What does it mean? It means that all the sub-watershed in the study area are still undergoing intense erosion. And when I'm saying undergoing erosion, this is a geological scale. It's not to say that last year it was the erosion was this way. This is at geological scale, time scales, And as we will see later on, the correlation with the actual erosion happening there is still small. In terms of soil erosion estimation, as I mentioned, there are 5 factors that were calculated. This is the rainfall, this is the soil, this is the topographic factor, this is the land cover factor, and this is the support practice factor. These are the maps. It's not necessary to go into numbers, but as you can see, for instance, for the topographic factor, you can see always here in these maps, the high means bad. It's higher erosion. Low, it's better. It's low. Like the overall equation is to multiply all of these. So if you multiply all these and there is somewhere some of these that have low values, so the soil loss will be low. So when we have red, it's bad. It means there is a susceptibility of high erosion. When it's green, it's better. The final result, this one, this is the final map, this one. So it shows the soil erosion after multiplying all these factors. And the total was found to be 12 ton per hectare per year. And I had to discretize, if I can say, to make this soil erosion risk factor so that I can make the correlation. The aggregation method I used, the statistic I used is mean. It would have been better to use the median, but since this is a continuous raster, it was difficult. I have some ideas from my supervisor, but for the time being, we use the mean statistic to create this soil risk profile. For each sub-watershed, we calculated the mean soil loss in that sub-watershed, and that's what we put here. And now for the correlation between hypsometric integral and soil erosion risk, we conducted a linear regression, and we found that some 7%, the R squared is 0.07, so it means that 7.7%, that almost 8% of the variation in the variation in the erosion was explained by hypsometry. So you can say this is small, it's a small correlation, but if you are trying to prioritize erosion, if you can already be sure that this area has 7% higher chance of erosion than the other, you can have a starting point of prioritizing your areas. But also, what's interesting is that the p-value was small, which means that this 7.7% relationship was genuine. It's not due by chance, if I can say. So you are confident that this relationship we are looking at is genuine. So this is almost already good, but in my recommendations, I'm suggesting that we include many other morphologic metrics in the correlation analysis. So we make a multivariate analysis so that maybe if you reach 30% of the variation, it will be already good for prioritization, so that you can say, I can use morphometric analysis as a prioritization scheme for soil erosion in an area. Some challenges I met during this study. There are some data sets, for instance, like I said, on soil texture data. I wanted soil texture data. Locally, this kind of data set is not available. I was told the project, which there is a national project ongoing right now, which will have such data, but this will be like next year. So I had to use data from international databases, which not always good because sometimes this data set are coarse. The resolution for this one, for instance, was 250 meters, while I was looking at the scale of 10 meters resolution. So I had to resample this one. So it was one of the challenge. Another one was the accessibility of data. The data I was able to get access to is the Sentinel data, the freely available. That's 10-meter resolution. But for mapping, for instance, run practices, like you want to see where the terraces are, because these ones I had to do manually. You want to see where there is a banana plantations or where there is some kind of agriculture practice that requires matching and so on. So this one I needed very high resolution map data. The data is already available in Rwanda. There's a mission, World View mission that covers the whole Rwanda. The images are there in the National Statistics Office, but the administrative procedures to reach that data were too long compared to the timeline I had. So I have to make do with what I had. I used Sentinel-2. Another challenge was COVID. That's general, but it only affected my timeline. Otherwise, it didn't affect the quality of my work. So thank you. That was what I had to say. If there are some more needed clarification or questions or contribution inputs, comments, all these are welcome. Thank you, Chair.
Thank you, Faustin, for your presentation. One simple question that I have. From your analysis, which areas should be prioritized?
Normally, if you look at here, this is the map. It shows the area which are undergoing much erosion. These ones in red, they are the one to be prioritized. But this map was calculated, was established using Russell. So that's what I wanted to avoid. We wanted to see if we can arrive at such a map without using Russell, by using isometric analysis. Yeah.
Right. Do we have? Yes, we have some questions in the audience.
Smaller than that, 0.03. So it's smaller than that. So that's why I said this relationship was not due by chance. That's what you. Okay.
Yes, I'm asking at the significance of that p-value. Of course, I see your R squared there is 0.07. That is the coefficient of determination, which is quite low. Yeah, it should be approaching 1.
Yeah, I get you. And I mentioned that this is a small explanatory. So the explanatory power of hypsometry vis-a-vis erosion in a landscape, at least in my study area, was small. So hypsometry was explaining only 77% of the variation. So it's small. But I was suggesting that in future studies, if you include maybe other morphometric indices, you can at least reach 30%, if I can say. So if you reach 30%, you are in an area you want to prioritize, you want to make a quick analysis of area to know which area to prioritize without going too far into deep soil loss studies. Then if you have a quick way to get, because a morphometric analysis is something you do on desk. It's not, doesn't require you to go on field, provided that you have detailed digital elevation models, and these ones are available nowadays very cheaply. So I was saying, if you can reach 50%, that will be good. Here we are still at 7% using only one morphometric analysis. Here I only used hypsometric integral. So if you use others, there are many other morphometric indices. Maybe I was hoping we can increase that. But at least, what I was saying, at least we know that this is genuine. This relationship we are looking is genuine. It's not, we didn't reach that by chance. Thank you. Doctor, did you do?
Thanks. Mine is just a very quick one. One, I was just curious about the source of the DEM. And two, in light of the work you have done, what would be your management interventions you would recommend? What, if your boss asks you, you have been on this master's for 1 or 2 years, what would you recommend from a management perspective? Thank you.
Okay, thank you, Dr. Anthony. The source of the DM, we have in Rwanda a DM that was developed by former Rwanda National Resources Authority, we called RNRA. Now it has been disbanded, but the data set is still available, not in publicly shared. Like we're looking at the special data infrastructure in Rwanda. We don't have yet such a facility, but at least that data set is available. But we also have another one with good metadata, and so but that one is 30 meters resolution. So I used the one with 10 meter resolution. Regarding recommendations, like I said, we are still low in terms of saying we can use hypsometric analysis as a predictor of soil erosion, because the relationship is still low. So I was recommending to continue the studies to increase this relationship by including other morphometric indices. There is a few I have suggested. So I hope anyone will come after me and conduct this analysis, or myself in the future, I could continue with this kind of work.
Thank you very much, Faustin, for your presentation.
Thank you.
The next presenter is Ms. Lynn Gasheri, and she'll be looking at modeling the implications of climatic, biophysical, and anthropogenic activities on river sedimentation. And she's from Dan Kimathi University, Kenya.
Thank you for this opportunity. My name is Lynn Gasheri Kaberia from Dedan Kimathi University of Kenya in the Institute of Geomatics, GIS, and Remote Sensing. My topic is modeling the implications of climatic, biophysical, and anthropogenic activities on river sedimentation, a case study of the upper Ewasonyiro River Basin in Kenya. On the introduction, we know that the river basins are very important, therefore the cost to really protect them. Sorry. Okay, so the soil conditions of a basin strongly depend on these hydrological conditions, as well as the biophysical conditions, and also the biological diversity. So the changes in the soil affect and challenges the natural resources, and therefore leading to high sedimentation rates, which may further lead to low agricultural productivity. So the Ewasonyiro River Basin is the largest in Kenya, and it is suffering from soil sedimentation rates. So these extreme climatic events and human interferences have led to increase in both runoff and the sediment to the river systems. So the soil sedimentation of the Ewasonyiro River Basin, if studied, could help understand the natural dynamics of the process, and this will be important for evaluation of the socio-economic and environmental impacts which necessitate the soil sedimentation. The problem statements, due to the varying climatic variabilities and the human activities, the increased soil sedimentation rates of the region pose a threat to the river basin. This also poses a threat to the natural availability of this Ewasonyiro River Basin. By doing that, it has negative impacts to both the local, social, and the economic development of the basin. These has impacts on the pastoralism, ranching, and even agriculture. A very good example is one of the counties in the river basin, the Laikipia County. It has more than 75% of their household income relying on agriculture, and of course this employs more than 60% of the county's population. So it is therefore urgent to assess this specific problem. On my objectives, the general objective was to model the implications of climatic, biophysical, and anthropogenic activities on river sedimentation. The specific objectives, the first one is to evaluate the climatic, biophysical, and anthropogenic variables that influence sedimentation from 1990 to 2020. Then the second one was to model the sedimentation rates using the modified ASO model, the MASO, and then to predict the future scenario of the river sedimentation by 2030 using the CA Markov chain analysis. So this is the study area map. The Upper Ewasonyiro River Basin covers an area of roughly 15,200 kilometers squares, and it has been experiencing a very high population growth, arising mainly due to the immigration and also the nomadic pastoralist. Again, I give an example of the Laikipia County. The population has tripled over the last 3 decades. Right now in 2009, it was roughly 399, 227 people. Also, it is also rich in wildlife ecosystem and are home to a large wildlife and livestock population. So these were some of the data sets that I had. I used Landsat from USGS with a 30-meter resolution to be able to get my soil moisture, lineament density, NDVI, and land use land cover. I also used the DEM from Alaska Satellite Facility. It is a 30-meter resolution resampled to 12.5 resolution. I also had the rainfall data, soil data, as well as the questionnaires that aided in my field work. It's not really clear from here. So I had several data sets. The first one was the rainfall data, the DEM, the Landsat, and also the soil, as well as the interviews. From the DEM, I was able to get the slope and the flow accumulation, which gave me the LS factor. And then from the Landsat, I was able to derive the soil moisture. I was also be able to come up or perform the classification and acquire my land use land cover maps. From there, I was able to come up with the safe factors. I also used the NDVI as my management data. That is the P factor from the Landsat. So I also had the soil. I was able to come up with the geological soil groups. And then, of course, I was able to derive the K, or the durability factor. So all those factors were the requirements for the modified soil parameters. But because I was using another model, I had first of all to delineate my watershed. So I used the HEC Geo HMS model. That is the hydrological engineering sector, hydrological modeling system, or the geological system. So it was able to delineate my watershed, and I was able to come up, I narrowed down to 4 sub-basins. So when I came to the modified ASO parameters, now I used another model, the HEC HMS now. So I was able to input my parameters. and I was able to attain the river sedimentation using the HMS model. But for me to be able to predict my data for 2030, I used the MAT criteria evaluation. So and the factor standardization. Of course, I was able to give the weights according to the interviews. So I did all that. I did the aggregation of all the suitability maps. Then I was able to do the WSC aggregation and came up with the several suitability maps. And then, of course, I ended up with just one suitability atlas. When I came to the modeling, the CA Markov, the river sedimentation, that is from my HMS, that is from 1990 to 2020. I was able to put it in the Markov. I was able to come up with the probability matrices, the contiguity filter of 5 by 5. So I was able now to be able to get the results of 2020. I first of all predicted for 2020 in order to validate my model. From the results, then I could be able to tell if I should continue with the prediction to 2030. So I had to validate my model first. So these are some of my results, the land use land covers. My research was from 1990 to 2020. I had roughly six classes. I had the forest and the bare land. I had the cropland. I also had the water bodies, the grassland. So you can be able to see how they have been changing over the time. I performed the accuracy assessment of the land use land cover maps, and I was able also to be able to represent them in terms of graphs. This was the soil moisture that was extracted. So it had the values ranging from, in my case, 1. So the higher soil moisture, of course, it leads to the high rates of sedimentation and vice versa. So the lineament density, we know that the lineament density indicates areas with high water content, and of course this also leads to high sedimentation rates. So they had to reclassify my data into 4 classes, with from very high to low sediment yield. We also had the NDVR, so I did for the 4 decades of the 3 epochs. So and the values, of course, ranges from 1 to -1. So the K factor, or the soil erodibility factor, it was described the resistance of soil erosion and depends on soil properties and particle size. So it ranges mine from 0 to 1, with 0 indicating areas to high susceptibility to soil sedimentation. I also went ahead and derived the LS factor. So it depended on the length and slope of the terrain. So the lower values of the LS factor indicated the flat slopes, while the high values indicated the steeper slopes. I also had the C factor, which is the impact of the land cover to soil sedimentation. It ranged from 1 to 0.001. For example, 1 indicated bare ground, and of course a bare ground means that we have low soil sedimentation. We also had 0.1 indicating thick vegetation, resulting to the high sedimentation. So these are the results of the HMS. I said it's the Hydrological Engineering Center, Hydrological Model System, the HMS. So I was able to delineate or come down to only 4 sub-basins in the entire river basin. So I had 4 of them. So these results showed the peak discharge on the highest time of the peak of that river. So I went to each and every sub-basin. They had names. The first one is the sub-basin W1 and 10. So this just shows the relationship between the depth and the flow. So I did this for the 4 sub-basins that I had. Then after this, I was able now to go to my second objective, which was the sediment load. So according to, for example, the sub-basin W110 and sub-basin W1000, they had very similar characteristics. Like for example, in April, both in 2020, the yellow one is in 2020, it had around 500,000 tons. When it came to W1000, the same time, it had 700,000 tons. Meaning that this sub-basin is larger, of course, but it also has high rates of sediment load. So, and also the other 2, which is the sediment 670 and the sub-basin sits 70 and 780. So 780 and the lowest sediment loads compared to the other first two. And of course, most of these high sediment loads were experienced in the month of April in 2020. So I went ahead to represent my data spatially for move maps to be able to know the progress or the consistency of these results. So from 1990, this is done in color red. It was sub-basin 1000, and it had the highest sediment load because, of course, you have a lake here, Lake Olsobot, forgive me the name. So we have this one having the high sediment load in 2020, followed by this other one. Then I had the 1000 here, and then finally I had the 780 sub-basin. So if you realize from 1990, 2000, and 2020, they were consistent. But when it came to 2020, the 670 and 1000 kind of interchanged. So this one does not became the highest, or this is very high, this is high, medium, and still maintained to be the low. So from these graphs here, I can be able to tell that these two, if I can say color yellow and gray for 2010, interchanged from color yellow and gray in 2020. So the color yellow here, or this sub-basin, had a lower sediment load compared to the gray one. But when it came to this other one, so they interchanged. So when I came to the Markov-C analysis, I had first of all to validate my data. So I predicted first of all for 2020. So I compared now, this is results from the HEC HMS, and this is the predicted results from the MC analysis. So the validation showed a good agreement between the observed and the simulated maps in 2020. The evaluation between accurately classified, so I had accuracies. I had the location accuracy or the no accuracy, which was 0.94. I also had the accuracy to specify or location correctly, the K location was 0.98, and the strength or to specify the quantity, which is the location structure, was 0.98. So the ability of the model predicted to attain complete classification, the K standard was also 0.93. So this means the kappa statistics between the observed and the simulated gave us score of 0.9, therefore validating the MCA model. So I was able to predict my river sedimentation for 2030. So we had this one, the W110 still maintained to have the highest sediment load, followed by W1000, then I had 670, and finally the 780 still maintained to have a low sediment load. In conclusion, so this study proved that the river basins are really being affected due to the varying sediment loads, and the failure to regulate the current land practices will greatly affect the nature and the productivity of the river basin. It is recommended to use the HEC HMS for the river sediment load analysis, as it showed great consistency in the results. It was able to show results both from the pervious and the impervious areas in the river basin and routed to the streams. Also, the projected results can be used to address the problem by regulating the anthropogenic activities on the river basin. It can also be used to the policymakers to help them mitigate the problem. Stakeholders like NEMA, for example, could use the results to advise and provide guidance on the implementation of environmental intervention. Thank you.
Thank you very much, Lynn, and thank you for your presentation. One observation that I saw within your data sets, there are some data sets that were at 12.5 meters and others were around 30 meters. So what was your final resolution for your models?
So for the 30 meters were the Landsat data, which was the 30 meters. But remember now for the DM, it was 30, but resampled for 12.5 to end in the analysis.
Great. Do we have questions in the audience?
Yeah, thanks, Lynn, for your good work. Just a quick one related to the previous question. Now that we have Sentinel that is freely available, how do you think that would impact on your work? I know you've used Landsat, that is 30 meters. We have Sentinel, which is 10 meters. Would there be value in exploring it, either in your work or some other work?
Okay, thank you for the question. I didn't really explore Sentinel because I was going back to the 1990 studies. So I realized I can't really meet the result for Sentinel and Landsat because I was going to 1990. So I think when you explore, because it has a higher resolution, maybe it can be able to improve the results.
Great. I think those are the questions that we have from the audience. Do we have any questions from the online? Okay. We'll select, I think, around 2 questions. So I don't know if it's possible for someone around there to do the reading. I seem not to see them clearly.
So it's here. We're expecting to see the different land units with the different levels of the expected total soil loss in Yen's catchment, which you did not see. How do we prioritize conservation if we do not have the total soil loss of the various units? So I dealt with soil sedimentation and not.
Yes, it was for Faustin.
Okay.
Now, I think we'll do a small session at the end that answers the previous questions. So I wanted the questions that are specific to Lynn.
I think it's here. How did you relate lineament density with sediment? So lineament density, also high lineament density indicates areas with high water content, and therefore now I can be able to relate it with sedimentation. I was able to reclassify my data as with high values and the high lineament density values indicating the areas where we have the high water content, and that is directly related to the soil sedimentation rates. I think I hope it's answered.
Yeah, sure. Thanks.
Okay.
Thanks, Lynn, for your presentation.
Thank you too.
So the next one is Neiwei. Neiwei is from the School of Earth Sciences, University of Addis Ababa. And he'll be discussing mapping the effects of urban blue-green landscapes effect on land surface temperature using geospatial technologies. And the case is within Addis.
Okay, thank you everyone. My name is Noel Kefle. I'm a remote sensing and geoinformatics student in Addis Ababa University, Ethiopia. And my research title is Mapping the Effects of Urban Blue-Green Landscapes on Land Surface Temperature using Geospatial Techniques. It's a case study of Addis Ababa. So this is my presentation outline, which I'm not going to read it. So I will start my introduction by defining urban blue-green landscapes. So according to the UN Habitat, urban blue-green landscape refers to all the green and blue areas in the city, including parks, private gardens, rivers, ponds, and riverbanks. And several studies have shown that this urban green landscape could absorb carbon dioxide, release oxygen, lower the air temperature, increase air moisture, reduce dust concentration and noise level in cities. So like the green landscapes, urban blue-green landscapes also provide ecological services like carbon sequestration, oxygen production, noise reduction, microclimate regulation, and recreation and social services in cities. And remote sensing, particularly thermal remote sensing, is very significant in monitoring land surface temperature and assessing the thermal properties of Earth's surface materials, as well as their relationships. So as a statement of the problem, so the governments, the different successive governments in Ethiopia have different priorities and projects regarding the development of the Addis Ababa city. For instance, Imperial Minilik was interested in building the National Palace, introducing the first gravel road and the marketplace in the city. And then is Imperial Haile Selassie, who was known for building the monuments, the Lion of Judah statue, and the Holy Trinity Cathedral Church in the city. And then comes the Derg, who restored the Mescal Square for its military parades and took the imperial properties. After that is the Ethiopian People's Revolutionary Democratic Front, the EPRDF, who was known for introducing the first light rail transit and expansive condominium social housing scheme in different parts of Addis Ababa. And more recently, the current administration introduced a new green intervention called the Green Legacy Campaign, and also the Beautifying Shaggar or Addis Ababa mega project in the city. So during the first Green Legacy Campaign, which was held during the rainy season of Ethiopia, so 4 billion seedlings were planted across the country. And at the second campaign, which was held in 2020, 5 billion seedlings were planted, that is across the country. And when it comes to into Addis, during the second campaign, 7.8 million seedlings were planted in the city. And on the other hand, the master plan of the city has also developed strategies that focus on the blue-green developments in the city. And the mega projects like the Beautifying Shaggar project clearly illustrates the government's focus on the blue-green intervention in the city. And this mega project is expected to raise the green coverage of the city from 0.3 to 7 square meter per capita. So this is part of the recent blue-green intervention, which is found in front of the National Palace in Addis. So this shows us a political shift in ideology and priority in the urban development of the city. And this study is mainly intended to map the urban blue-green landscapes effect on land surface temperature using geospatial techniques. So objectives. The main objective of this study is to map the effects of urban blue-green landscapes on land surface temperature using geospatial techniques. So in line with the main objective, this study has 4 specific objectives. The first one is to estimate land surface temperature for the 3 different years in the city. The second one is to map the land use land cover using object-based image analysis and high-resolution imagery. The third one is analyzing the spatial-temporal pattern of land surface temperature and its variation among the different land use land cover classes. And finally, to study the impact of the urban blue-green landscapes on land surface temperature using the vegetation build-up and water indices. So this is my study area map. So regarding the materials, methods, and softwares, so this is the flow chart for this study. As you can see here, this study is conducted in 5 stages. The first one is data collection, in which data was obtained from different sources. For instance, I used Spot 5, which is commercial one, and also Sentinel-2, which is freely available with a resolution of 10 meter, and then also Landsat 718 Plus and Landsat 8 with a resolution of 30 meter. I also used MODIS land surface temperature product with 1 kilometer just for the validation purpose. And for the classification accuracy assessment, I also used field data and Google Earth data. So the second stage is image pre-processing, where different kinds of image pre-processing activities were carried out, like atmospheric correction, skyline error correction, and so on. The third one is image enhancement, where I calculated different land use land cover indices like NDVI, NDBI, and modified normalized difference water index to enhance vegetation, build-up, and water indices respectively. And then is image classification, which is the fourth stage. Actually, image classification and the land surface temperature retrieval, where object-based image analysis is applied to classify the land use land cover, together with its accuracy assessment. And also land surface temperature retrieval is also carried out using the bands from Landsat 7, band 6, and from the Landsat 11, from the band 10 from the Landsat 8 tiers band, together with its validation. And the final stage is statistical analysis, where I used linear regression to determine the relationship of land surface temperature against the 3 land use land cover indices. And these are the list of the softwares that I used. So these are the equations that were applied to calculate the land surface temperature. So to standardize the land use land cover classification, I used the USGS classification system. So I do have the built-up, the vegetation, urban farmland, pearland, and water land use land cover classes. So these are my results. So for the accuracy assessment, you can see, So this is the result for the overall accuracy assessment and the overall kappa statistics. So it shows above 90, indicating that the classification is it highly agrees with truth in the ground. So for the land use land cover change, the statistics. So as you can see, the built-up land use land cover class showed an increasing trend for the last 15 years at the expense of vegetation, urban farmland, and pearland. And the water land use land cover class remained relatively unchanged. So when you look at the last column of the table, you can see the annual rate of change for the built-up class. It's a 4.38, which is 9.27 square kilometer. And the others, and these figures shows that the vegetation, urban farmland, and pearland are diminishing through time in the study area. So this is the map for the land use land cover change for 3 different years. A is for 2006, B is for 2016, and C for 2021. So the one at the middle, the one which is represented by the cyan color represents the built-up. So you can easily understand how the built-up land cover class expanded through time at the expense of the bare land, which is highlighted in red, and the urban farmland, which is in yellow. And you can also see the vegetation cover at the at the north, where there is in total mountain. It's densely vegetated, and also along the river banks in the city. So this is the land use land cover conversion matrix, which shows you which type of land use land cover is changing into what. So I highlighted it with red. You can see here how the bare land changed into the built up by 59% during the last 15 years. The urban farmland changed by 53.73 into built up, and also even the vegetation itself changed into the built up by 48%. So this is the result for the land surface temperature validation. So 86%, 81%, and 80% of the pixel values extracted from the Moody's land surface temperature and the estimated raster showed a maximum difference of plus or 2 degrees Celsius. And you can also see the result for the spatio-temporal pattern of land surface temperature. As you can see, the mean land surface temperature showed an increasing trend during the last 15 years. And considering the whole range of time, from 2006 to 2021, the land surface temperature in the city increased by 2.4 degrees Celsius. And this is the map for the 3 different years. So as you can see, the one highlighted in blue is lower land surface temperature values, and the red with the highest one. So the lower land surface temperature, the lower mean land surface temperature values are observed where there is vegetation in the northern part of the city, and the higher values are mostly, observed in the central and southern part of the city. So this is the result for the land surface temperature for the 5 land use land cover classes. So as you can see, the one highlighted in green shows you the lowest mean land surface temperature values. So the lowest values for the mean land surface temperature were observed among water and vegetation land use land cover classes. So on the other hand, the higher values were observed among the urban farmland and bare land use land cover classes in the city. So this is a regression result for land surface temperature with any DVI, any DBI, and the water index, M and DWI. As you can see here, the Pearson moment correlation coefficient, which is R, it tells you that the NDVI is negatively correlated with land surface temperature, and the NDBI, the built-up index, is positively correlated with land surface temperature, and the water index is negatively correlated with land surface temperature. And also the R square values tells you it is higher for NDVI and NDBI, but it is lower for the water index in all the 3 years, indicating that most of the variations in the land surface temperature are explained by NDVI and NDBI compared to the water index in the city. And this is the scatter plots of NDVI and land surface temperature for the 3 different years. So for your visual interpretation. And here comes the scatter plot for land surface temperature and NDVI for the 3 different years. And this one is land surface temperature against modified normalized different water index. So as a conclusion, the findings of this study reveal that there has been a substantial transformation between land use land cover classes, and the expansion of built-up areas is the most prominent phenomenon and is responsible for the shrinking of urban farmland, bare land, and vegetation coverage in the city since 2006. And the findings indicated that land surface temperature varied both spatially and temporally throughout the study periods. And the land use land cover alteration had contributed to the modification of land surface temperature in Addis during the study period. And like I said, NDVI and NDVI are the 2 most important parameters to predict land surface temperature in the study area compared to the water index. And lastly, this study witnessed the potential of integrating remote sensing and GIS for investigating the urban thermal environment with respect to different land use land cover classes. So these are my recommendations. The first one is, the urban planners and policy makers has to consider diversified green landscapes like green buildings with green walls and roofs, street greening, small and large parks, and green trails and playing grounds in the city. And it's also recommended that planning and designing should be based on changing and future demands, and the blue-green development opportunities should be promoted and extended into other sectors and projects like schools, real estate, shopping centers, and so on. And it's also recommended that it would be beneficial to consider the construction of man-made lakes within the green areas because it helps to strengthen the cooling effect, and as it was a case in the Friendship Square in Addis. And the authors, finally, the authors realized that some other driving forces of land surface temperature other than land use land cover dynamics like altitude and some other factors are not considered in this study. And also we believe that the temporal extent should also be widened to better understand the land surface temperature trend and the associated land use land cover change in the city. This is the end of my presentation, and thank you very much for your time.
Thank you, Newe, for your presentation. Do we have any questions in the audience?
Yes, we have many.
Please speak loud.
We have many please. Land surface temperatures. We have the maximum temperature, we have the minimum temperature, and the average. So, which one did you use in your analysis? And again, another question is, in the cities we have the impact of the urban heat highlands. So, did you incorporate it in the study?
I understood your first question, but for the second one, maybe you can speak it loud.
Yes, so for the second one is, I'm asking about the influence of the urban heat island, mostly in the cities, and how it impacts your study.
Okay, its impact on the city?
Yes, on your study, the UHI.
On my study, okay.
Yes.
Okay, for the first question, no question, I used the mean because the mean is, as you know, it's the central value, and for the analysis, instead of the maximum and the minimum values or other statistics or maybe standard deviation, for analysis purpose, for the comparison, I used mean. So for the urban heat island, so like in every other city, this phenomenon is also observed in the city. So I think this study is going to be if they apply it, it's going to be the solution for the urban heat island effect. So one way of mitigating the urban heat island effect is to intervene by developing green areas, which is, by the way, the government is making some interventions right now, a massive one. 56-kilometer river basin is developing for green and blue areas in the city, and this is one mitigation, one way of mitigating one. I have also recommended some points to sustainably mitigate the urban heat island effect. Thank you very much. Maybe I can explain it if you are not happy. Maybe I will explain it later. You can ask me again. Okay.
Yeah, just a short one. From your results, it's evident that you've been losing vegetation over the years. Not so. And yet, you have talked of how many seedlings being planted? 55, what was it, 1,000?
That's across the country.
Okay, so
not in Addis.
Not in Addis.
Yeah.
So that's not happening in Addis.
Yeah, at a small scale.
Because my question was going to be, does it mean that the interventions are not yet working, are not enough, or it is too early to gauge their impact?
Yeah. So first, it's too early, but if you look at the numbers for vegetation here, it was 105.02, and then it became 95.33, it became 95.87. Look, there is a very slight increase because of very slight one. I think it's because it's too early. It was expected to decrease, but it showed very slight increase, maybe less than 1 square kilometer. And that's promising, a promising one, I think.
On this very page, how do you explain the negative percentage for the bare land?
Okay, this one?
Bare land, the negative 4.56.
4.56. Okay, that means it's decreasing by 4.56% per year. And that is 3.08 in a square kilometer. So the number is going down. Its area is shrinking from time to time, from year to year by this number, by 4.56. Okay, Faustin?
Yeah, thank you, Mr. Bekere. Mine is a very minor curiosity issue. You mentioned that in the software section that you use the QGIS and the ArcGIS.
Yeah.
So I was curious to know, for instance, you give us an example of something you wanted to do with ArcGIS, but GIS couldn't do, or ArcGIS couldn't do, because in my opinion they overlap. So why did you have to use the two?
You know, it's based on the user. For example, I prefer ERDAS Imagine for processing images. I am familiar with ERDAS Imagine as opposed to ArcGIS. So I particularly I used QGIS for atmospheric correction. There is an option called dark object subtraction. It's very easy to carry out this correction on QGIS than INVI or whatever other. That's why I chose QGIS. And for the recognition, it's for the object-based image analysis. Which one? ArcGIS? Are you asking me the difference?
QGIS, number 3.
This one?
And the first one.
This one?
Why do you need the two?
ArcGIS?
And QGIS.
QGIS. Yeah, for image pre-processing, particularly for atmospheric correction. You can also download data from Landsat, Aster, whatever, using this software, using QGIS.
Great. Thank you very much for your presentation. So the next presenter is Mr. Gola Clinton, and he'll be presenting the potential impacts of rainfall variability on water availability under changing climate. He's from University of Nairobi.
Work I've been doing on potential impact of rainfall, variability on rainfall, on water availability over Takwe River Basin, a case study in Kenya, in a changing climate. I'm Clinton from Department of Earth and Climate Sciences, University of Nairobi, being supervised by the two, Gilbert Ouma and Dr. Stephen. So on the background of my studies that we find globally the rainfall variability has been increasing, and this can be seen by work done by Schroeder 2010. And when you narrow it down to the region East Africa, a study by Wangesho 2013 revealed that the Asara region of the Eastern Africa has been experiencing increase in rainfall. And therefore Kenya is not exempted because it falls within the region, and it has also been experiencing rainfall variabilities. What we find now, we narrow it down to Turkana County, where the study area is, which is mostly pastoralism, livelihood zone, and it forms 60%. So you see, these people, they depend on water and also the rainfall for the pasture to grow. But this has been affected by the climate change. Of course, the increase in climate leads to poor pasture formation. Yeah, so you find sometimes the animals die. So in that case, a study which was also done by Ferreira 2018, we found that the 41% of the total population, of the total precipitation within the basin is always impounded at the Takwe River Dam, which you are going to see in the study area. And therefore, along the river, we have the boreholes dug where the communities drill water for their use. So with that, you can justify that stream flow can be used as a proxy to water availability, because most communities depend on water from the river. On the problem statement is that water availability is a major problem, and you find during low flows, we have little rainfall, which leads to drought, and during high flows, we have floods, which destroy people and properties. So the objective of the study, the main one is to assess the impact of rainfall variabilities on water availability in the Takwe River Basin under changing climate. In order to achieve the main objective, these 4 specific objectives were analyzed. First, I determined the temporal and spatial extent of rainfall over the study area. The second was I determined the temporal trend of stream flow. Of course, rainfall and stream flow relationship became the third. And the fourth one was on the impact of the future climate on water availability. So in the study area, this the study area, and you can see it is falling in West Pokot and Turkana County, and the basin stretches like this. So it originates from the western side of Mount Elgon, And all these tributaries, they bring water and empties into Lake Turkana. On the water sources, we have many boreholes, dams, water ponds, shallow wells, and even the small streams, lagers. On the climate of the area, according to, of course, climate classification by Copenhagen, this region was classified as hot desert climate, BHW, and therefore, of course, it experiences 2 rainfall seasons during March, April, May, and October, November, December. On the governance and the water resources, we find that the county, Turkana County, has county integrated plan, which is used to manage its resources, like regulating the environmental flows, and also the water and sewerage companies, because you find near the mouth of the river is where we have a large population, mostly on the Lodwar town. Yes, so on the data used, of course, the specific objectives were very many, so I used a lot of data, and the data used depended on the specific objective. Like specific objective 1, I used to observe rainfall data from our department, Kenya Met department, spanning 1981 to 2020 to validate the CHAPS rainfall data, which I was going to use because the area lacked most observed rainfall. To stimulate the stream flow, for the same period, 1981 to 2020, I used the DEM from RCMRD, the source is there. It was at 30-meter resolution, Sentinel-2 image at 10 meters was used, soil map from FAO at 600 meters, and then era 5, temperature maximum and minimum, was obtained from Copernicus climate data store. The source is there. The source is there. So for the wind speed, relative humidity, solar radiation, because these are the input requirements for the SWAT model to run, for you to generate the stream flow. Of course, these other sources which had good resolution were not providing this, so I accessed it from Power NASA data portal for the same period, although the resolution was 0.5 degrees, that is 50 by 50 kilometers. So for the relationship, I used the result in specific objective 1 and 2 and correlated to see how they relate. And for the future climate change, I used the Codex data models provided by World Climate Center, of course, on the Africa domain at 0.44 degrees. For the hindcast part, which is 1951 to 205, that's the historical, then the model runs up to 2100 for the 2 scenarios, the 4.5 and 8.5 RCPs. It was, I got it from the German Climate Computing Center. So this is the representation of the stations, data which were used. So on the method depended on the specific objective used. Like for the temporal spatial rainfall, first I validated the CHAPS rainfall with the observed using root mean square, and then variability analysis was done by coefficient of variation given by the mean, by the standard deviation divided by mean. But in this case, you express it as 100 in percentage. Spatial analysis was done for the rainfall using the spatial analysis tool in ArcGIS 10.8. And then for objective 2, I ran the SWAT model given by that equation where the final water content is given by the initial, and then you sum the number of rainy days, the surface flow, evaporation rate, underground seepage, then the return flow. For the correlation, I use the Spearman rank and Pearson correlation. For the future climate analysis, I use the CDO command line because it is a powerful tool for analyzing climate data, and also Python codes for computation. Yes. So this is just a flowchart of the process which is happening in SWAT. We have like the data preparation, watershed delineation, HRU definition, and then you edit the input. So in the preparation, you look at the climate data, you prepare them adequately in a manner that SWOT will incorporate them and generate your flows. So the result of the validations are these. On the subbasin 2, I validated the chaps versus the observed at Lauder Met Station, and that is how the seasonality behaved. So with this result, I concluded that since the observed agrees well with the graded, it is good to use the graded data, the chaps. Yeah, so from here, my analysis was based on the chaps rainfall. So some of the results of the analysis, this is the annual rainfall trend and the seasonal rainfall trend based on the Mankendall test statistics. And it's not visible, but what you can see is that for the upper basin, middle basin, and the lower basin, both of them showed an increasing rainfall trend. But as if this is not enough, I went to the seasonal rainfall trend, where an interesting finding was that during the March, April, May rainfall, there is no trend which was observed, but JJA and OND, there was an increasing trend. Similarly, in the DJF, there was no trend. Those are the statistics of the Mankendall. So on the seasonal pattern, of course, other studies have been done in the area, and they revealed that the area has bimodal rainfall. But now my study revealed that the area has got tri-modal rainfall pattern, 3 pattern. First happened in March, April, May. We call it in Kenya MAM. The second one is June, July, August. That is JJA. And the third one here we can see it is September, October, November, the SON or the SON. So that's basically the finding, and what we see is that the MAM rainfall is having high peaks. Of course, the graphs are for the 4 decades. So the first decadal period is from 1981 to 1990. Then from 1991 to 2000, 2001 to 2010, and then from 2010 to 2011 to current 2020. So what we find is that this period, there has been climate variabilities. Of course, the choice of the 10-year is that we look, in climate, we look at the longest climate cycle possible, and that is always the solar cycle, which takes 10 to 11 years. For these other cycles like quasi-biennial oscillations, like rotation of the earth, they take like 1 year, 2 years, which is not good for climate change. Of course, if you have 3 points, you can see the changes. 2 points, you can't see the change in climate. So on the presentation of the most conspicuous rainfall season, which is JJA and MAM, what I found is that in the JJA, the rainfall trend has been showing a north-south rainfall gradient. As you move from the upper basin towards the lower basin, from the lower to the upper, in this part we have high rainfall. the JJA season, we found that the rainfall is having the east-west rainfall gradient, a situation where the rainfall is maximum in the western part, while in the eastern part is dry. And this is attributed to the, of course, the movement of the warm Congo air mass during this period. It stretches this side and brings rainfall in Uganda and Western Kenya. So, of course, in Turkana we also have the East Africa low-level jet, a region with the high wind speed, but now it's low, so you can't find the rainfall. So on the variability, of course, according to a study by Harry 203, and the finding is that the region is generally experiencing high rainfall variabilities, as can be seen by the figures. Of course, it's greater than the limit of 30%, so it agrees well with other studies. For the simulation of the stream, it was done at 3 points, at the upper basin, middle, and the lower, just to see the lag time, water takes, let's say when it rains here, until it reaches the mouth of the river, and before the mouth, the populations are many here. So these people depend on water, which come from here. So these are some of the SWOT simulation. As you can see, from 1981 to around 2000, stream flow was negligible. Of course, there was a 3-year lag period during the run given for the mole to settle the hydrological processes. But from now, the year 2000 onwards, there's been high rainfall, which indicates a high stream flow for the region. So when correlated the rainfall stream flow relationship for the upper, middle, and lower, we found the same results. As you can see, years of high rainfall is associated with corresponding high stream flow, like this, the year 2018, across the basin. But now when I did the correlation of the season, like this MAM, JJA, SON, and DJF, the rainfall is too much in the MAM season, while in the DJF it is quite negligible. Yes, so this is the simulation of the, you can see how the video moves. Yes, so the first 2 diagrams are for the 1981 to 1990, then 1991 to 2000. If you note keenly, the river gets filled during the wet season, and it's north-south in this upper one, while in the 3rd and the 4th decade, the river gets filled, but most of water is from the western side of Uganda, as you can see. Of course, the simulation is over. So what we can say is that during this first 2 period, this was the time when the dam, the Turkwell Gorge Dam, was being constructed. And we had water obstruction in the dam for the dam to get filled, because the dam was built between 1986 to 1993. And it has to get a water capacity of these cubic meters. So it took time between these years. So people downstream were not getting water because it was being obstructed to fill the dam, and also the irrigation in that area, which was also taking place at the same time. So the correlation of the two rainfall stream flow is this. So it was first with alpha 0.05 at 90% confidence level and 95% prediction level. And we found that most points were falling. There are 2 colors. We have the green and the cyan color. So most points were falling in 95% prediction level, that rainfall can predict a stream flow. But yes, so when I did both Pearson correlation coefficient, Spearman rank, and the gradients, what we found is that all of them, in the upper basin, there was 0.87 correlation, and for Spearman rank is for 0.916. For the middle, Pearson was 0.929. Yes, Spearman rank 0. They're almost the same. And also for the lower is now the old basin, the simulation at that point. They indicated a value of almost 1. So, and then I looked at the lag time. Lag time is that when it rains in the upstream, which time, how long does it take water to reach the downstream? Because most people use water in the downstream. So what we find that in the upper basin, the lag time was 0. Of course, the analysis was done in months. Perhaps there was weeks, 2 weeks, 3 weeks can form a month. For the middle basin, there were 0 lag time. But now for the lower basin, the end of the river, we had 1 month lag. So if it rains in the upper basin, it takes 1 month for that water to be converted into stream flow and reaches the river. And it was so the same for the sound season. So the insights I got here is that this water needs to be quantified because people in the lower basin depend on it. So based on the equation on the lower basin, y is equal to this mx, so we can, if we have the rainfall data, we can feed into the equation and quantify the stream flow, which will reach downstream. So in the future scenario, on the Codex data model, I used the hindcast data for the validation of the model, then it picks and runs up to the future. So the hindcast data, they use the observation, it rained from 1951 to 2005, and then you give it different scenarios, like if we continue using the fossil fuels, how will the situation behave? RCP 85. If we come back to the green, to using the green energy, how will be the situation? It comes to 4.5. So out of the 19 models, based on the Pearson correlation and the root mean square error and the probability of the detection, how well does the forecasted predicts the observed? I found that most models from the Rosby Climate Center, the RCA4, were capturing the rainfall over the region. That is like, you can see the one highlighted from the Canadian Earth Simulation Model. Of course, that is the GCM, used to downscale that codex. From, yes, I also have the RCA from that. Yeah, from the Japan, the Miroc was also capturing, and the Hadley cell from the UK, Met Office was also capturing, and also from the Max Planck's Earth Simulation models. Those are the GCM used to scale. Yeah, so after doing this validation, I was convinced that being that these 6 models correspond with the CHAPS rainfall, which had already validated, which is the bars. So the 6 models were now used to run the stream flow simulation into the future. How will the future water behave now that climate is changing? So in the future, this is the result which came out. So the study was centered 2030 and 2060. 2030 was chosen because in our country, we have our Vision 2030. So when it was centered 2030, it ran from 2015 to 2044. And I also centered it at 2060. Of course, the 2060 African Union agenda to see, of course, they have the agenda like what they have is transforming Africa into a powerful house. Now, water climate comes into a main role here and the food securities. So for our country, Kenya, we have the Big 4 agenda, and agenda number 1 is food security. People must be able to get food, and water is a critical factor. Water is used for agriculture, for food production, so that comes into play. Another result of the finding is that, of course, we have the insight for the county, Turkana County, like the one managing water, the Lowasco, it's called Lodwa Water Sewerage Company. They can control the policies they use to manage the water, the environmental flows, they regulate the irrigation, and also they release the water to reach into the ground. So what the result found is that, of course, under business as usual and under business unusual. The unusual business is we will continue burning fossil fuel, mining coal, using petroleum product, and that is classified under representative concentration pathway 85. That is the warming potential. By 2100, we shall have reached there. So you find the red one is the RCP 45. When we now convert to use of the geothermal, the solar energy, the wind, we will be having a reducing stream flow. Of course, it will be higher than the RCP 45 up to 2044, after which there will be a discontinuity point where increased use of the green source of energy will lead to decrease of the stream flow. But now, increased use of petrol, coal, or whatever will lead to an increase in rainfall. And then this answers the paradox we have, like the East African rainfall paradox, because you find most models predict enhanced rainfall, while the opposite is true for this case. So the insights is for these sectors, the counties. Of course, our country, Kenya, this study is done in just one basin. Of course, can be extended to other basins. Yeah, also, of course, can be extended to AU Agenda 2060. Of course, the study is centered 2060. Thank you.
Thank you very much, Clinton, for your presentation. Questions from the audience? Okay. Do we have any questions online? Not yet. Great. Thank you very much, Clinton, for your presentation. The next person for the presentation is Rahel, and they'll be presenting volcanic hazard and risk assessment from future eruptions. And she's from Addis Ababa University.
Okay, thank you. Hello everyone, my name is Rahel Amante. I came from Addis Ababa University and my specialization is environmental geology and geohazard stream. My supervisors are Professor Gazahan Girgu and Dr. Binyam Tasfa. And my thesis title says Volcanic Hazard and Risk Assessment from Future Eruptions of Fantale Volcano, Northern Main Ethiopian Rift. These are the outlines: introduction, material and method, geology of Fantale volcano, and the surrounding region, result and discussion, conclusion and recommendation. I will start the presentation by defining what volcano means. Volcano is a vent, or it is an opening in the surface which allows the entrance of hot earth materials such as magma, hot gases and rock fragments to raise out into the surface. And those hot earth materials or magmas are stored within a large reservoir, so-called a magma chamber. So when they get an entry or an entrance, such as a ruptured surface, they raise it out into surface. And when they flow as a thin flow, which is called a lava flow, and when the viscous magma raised out into surface, which will form an eruption column, and when it collapses due to gravity, it will flow, and it's so-called pyroclastic flow. And when the pyroclastic column collapses, it falls as ashfall deposit. There is a volcanic hazard which is associated with a volcanic eruption, and it is so defined as the probability of volcanic eruption occurring at a given geographic area within a given period of time. And there are any factors which are associated with volcanic hazard, so-called volcanic risk. So volcanic risk is defined as unexpected amount of loss or property damage which are caused by volcanic hazards. There are different volcanic activities in the world, and East African Rift System is a well-known area having different active volcanoes inside. And there are two main segments in East African Rift System, such as main Ethiopian Rift and Afar Rift, where there are different active volcanoes took place. Study area description. The study area is located in East Shoa zone of Oromia regional state, North Shoa zone of Amhara, and South Afar region. And the whole area covers about 1,690 kilometers square. And it is far from Adama town by 96 kilometers and from Addis Ababa by 200 kilometers. There are different exposures in the study area, especially Awash National Park surrounds the Fantale Caldera. This is the boundary of Awash National Park. And when we come to the south of Fantale Caldera, there is a lake so-called Lake Basaka. And the main two towns in the study area, such as Matahara and Addis Katama, are here. And also there is Awash River, which is located in the southern eastern end of the study area. Statement of the problem. Volcanic hazard has different impacts in both living and different man-made activities. Many peoples in the world live around active volcanoes because of different resources which are generated from volcanoes, such as soil fertility, physiography, attraction, and also there are different geothermal features such as hot spring system in the area. So the area is surrounded by different economic activities, such as there is sugar plantation and Awash Malka farm land in the area, and also there is Awash National Park. So they are main for the key development of the country. And there is also infrastructural development. There is a railway which connects Addis Ababa from Djibouti in the area. And also there is a Matara sugar plantation. So those vulnerable or exposure will be harmed due to the eruption which is occurred during future. So the main purpose of this study is to assess the volcanic hazards on those exposures and in order to assess the volcanic risk from future eruption. Objectives. The main objective of the study is assessing and mapping the volcanic hazard and risk of the future eruption in the Fantale volcano. And there are different specific objectives, including reconstructing the past eruption history of the area in terms of geology and stratigraphy, identifying different magmatic vents and geothermal features such as fumaroles, hot springs, and mud pools in the area, preparing the volcanic hazard map of the area using satellite imagery, specifically Sentinel-2A image, and assessing the vulnerability and exposure of the area, such as populations, infrastructure, land use, land cover, different facilities such as health facility, religious facility, and preparing the volcanic hazard and risk map of the area. Materials and methods. Different materials were used for the study purpose, such as primary and secondary data. Field data, satellite imagery are among the primary data of the study. Field data were investigated for identifying different volcanic products in the study area and for identifying different geothermal features in the area, because those geothermal features are a good sign of volcanic unrest, and they indicate the presence of eruption in the future. And satellite imagery, so-called Sentinel-2A, was downloaded from the website so-called Copernicus Open Access Hub. The DAM, having 12.5 resolution, was downloaded from Alaska Satellite Facility. Tabular population data was acquired from Central Statistical Agency of Ethiopia, geologic map from Geological Survey of Ethiopia, and spatial population data was downloaded from DIVA GIS. And basically, remote sensing and GIS method was applied in this study. satellite image interpretation was conducted for generating different geological structures for assessing the lava flow hazards, such as fault structure, vent, and different geological structure were generated by using image interpretation technique. Another one is supervised maximum likelihood classification system. This method was basically applied for classifying both land use, land cover, and lithology classification. And another one is multi-criteria, GIS-based multi-criteria evaluation method. These were applied for lava flow hazard evaluation and for also risk assessment. And different factors are analyzed, and they have done thematic layer preparation for those evaluation using the GIS, ARC-GIS software. Within, there is one method so-called analytic hierarchy process, which is classified into categorized into multi-criteria evaluation, and it is a process of weighting factors based on their importance. For the lava flow hazards, different factors were analyzed based on their importance. For example, faults, vent distance, caldera distance, elevation and slope were analyzed through analytic hierarchy process based on their contribution for the lava flow hazard. And for lithology classification, the different lithology were identified based on band ratio techniques. For example, for welder tuff, 8 by 11 and 12 by 2 band ratio technique was applied. For alluvium, fine sandstone and basalt, 12 by 3 band ratio technique was used. And for rhyolites and trachyte lavas, 12 by 11 band ratio was used. And by using, by stacking the image, the classification was done. Geology of Fantale and volcanic and surrounding regions. Fantale is known to be a bimodal eruption history, implying there are both explosive and effusive eruption products in the area. So this stratigraphy shows the areas which are deposited during different caldera formation. For example, this is from top to bottom. It shows the oldest unit. This is the post-caldera activities are the younger one, and these are the Kasam basalt and Kasam ignimbrite are associated with plateau formation, then followed by pre-caldera or formation or caldera collapse, Fantale caldera. That are the unities which are deposited during caldera formation and post-caldera after the formation of Fantale caldera. This is a geologic map of Fantale volcano. As we shown, as the map shows, the voluminous unit, deposited unit in the study area is welder tuff. As we see, this is erupted before Fantale caldera formation and also during the Fantale caldera formation. And also there are lava flows, trachytes and rhyolitic lava flows in the study area, which are erupted from the center of Fantale volcano. And also this Dauphin basalt is not associated with Fantale volcano, and it is associated with 1G fault belt. And the plateau formation units such as Kasam basalt and Kasam ignimbrite look like here, and there are different geologic structures, fault structures here in the study area. This is Fantale caldera and Awash National Park boundary. Okay. The hazard assessment was done based on the theory of uniformitarianism, implying the inactivities which were happened in the past will be the key for inactivities which will be erupted in the future. So the presence of geothermal features such as femoral hot spring and mud pool aligned with normal fault indicators, the area is volcanically active and there is a volcanic unrest in the area. So based on the past eruption history and volcanic products in the area, by combining with those geothermal features, the expected eruption type and potential hazard of the area will be lava flow hazard, having high viscosity, silicic and low viscosity basaltic lava, pyroclastic flow, pyroclastic density current hazard, pyroclastic fall hazard, or tephra fall hazard. hazard assessment for lava flow hazard evaluation, the geologic features such as fault structures and vent location, those black things and difference are extracted. And this is the hillshade maps extracted from the DEM. So the 5 factors such as caldera, vents, faults, and elevation and the slopes are evaluated. So there are lavas which are erupted from Fantale caldera, trachytic lava. So as the caldera distance decreases, the hazard increases. So they have inverse proportional. The same for the vents. As the vent caldera decreases, the hazard also increases because the lava also enter into the surface through the vents. Fault is also another geologic structure which allows the entrance of lavas into the surface. So as the fault density increases, the hazard also increases. Elevation is the topographic parameter. The lava flows from high elevation to low elevation, and slope is another topographic parameter. The lava flows fast at a steep slope, and it flows slow at gentle slope. This is the factor evaluation map of lava flow hazard. The first one indicates caldera distance, vent distance, fault density, elevation, and slope. Then, after evaluating those factors, the pairwise comparison matrix was done for those 5 factors, and they was given different weights based on their contribution. For example, for vent location and caldera distance, they was given 0.36 because they both allow the entry of lava into the surface, then followed by fault, elevation, and slope. So by having those this weight, the hazard map for lava flow was done, and the consistency ratio is 0.03, which is less than 0.4. So this evaluation is acceptable. This is the lava flow hazard map of the study area. As we see from the map, the very high hazard concentrated at calderas, because so many vents are adjacent to the caldera, and so the trachyte and rhyolite flows are found in the very high hazard zone. Different elements are exposed for this hazard. For example, there is this Awash National Park is more nearby for this hazard, so it is more vulnerable element. And there is also a railway. This railway and Lake Basaka is also more nearby for the caldera, so they are more vulnerable elements. And there are irrigation farmlands, this Matara sugar plantation and Awash Malka farm in the area. So the more vulnerable element is Awash National Park, as we see from the area. And the very high hazard is classified, and it covers about 10.9% of the whole, the entire area. For assessing both pyroclastic and ashfall hazard, the lithology classification was done. As we see, different lithologies which were erupted during different time were merged as one unit. For example, both Welder Tuff of Tinish Fantale and Fantale are merged as Welder Tuff, and another units were merged, and this lithology classification was done. So the voluminous unit is Welder Tuff, classified as Welder Tuff, and there is lava flow products of rhyolite and trachyte. Then the old basalt unit is this one, light green unit, and the recent lava flows, which is called AA basalt, which are erupted from Tinish Sabobar or tuff ring. Pyroclastic flow hazard. This hazard is done. This assessment is done by reclassifying this lithologic unit, and the very high hazard covers about 36% of the area, the red one shows the very high class, then the yellow, followed by yellow, light green, and green. So this hazard is covers more area. So many exposures are vulnerable for the hazards. Another hazard is ashfall hazard or tephra fall. Ashfall deposits are more concentrated or deposited in the northern and southern part of the area. So the two towns, such as Matahara and Addis Ketama, are more exposed for the ashfall hazard in the study area, and the very high hazard spans about 9.7% of the entire area. Vulnerability assessment. Vulnerability implies the probability of those exposures, such as population, localities, and different economic activities, to be harmed by an eruption of Fantale volcano. So this map is a population map of the state area, a reclassified population map. Then locality, economic activity, health facility, different education facility, religious facility, and infrastructures, both road and railway. These are classified as vulnerability to assess the vulnerability of the area. And there is also land use, land cover classes. 6 land use, land cover class were prepared for the study purposes. And those 6 classes are reclassified into 4 based on their importance. For example, built-up was classified as very high, farmland and water body classified as high, and forest classified as moderate, and shrub and bare land was classified as low. Risk assessment. The risk assessment was done by combining both hazard and vulnerability of the area. So the hazard was given a very high weight, then followed by population, land use, land cover, locality. Then the other facilities was given the same weight. This map shows the risk of the 3 hazards. The first one is the risk of pyroclastic flow deposit, the risk of ashfall hazard, and the risk of lava flow hazard. As we see from the map, the red one shows the very high hazard class, and the light red shows the high hazard. Then the yellow shows moderate, and the green one shows the low class of the risk. As we see from the map, the hazard which has the highest risk is pyroclastic flow, because it is fastly moving and it is devastating. It covers a large area, so it causes more impact on living things and also different man-made activities. Then it is followed by ashfall hazards, and the last one is the risk of lava flow hazard. So there is limitation of volcanologic data in different parts of the world. So the hazard assessment is done based on quantitative measures, implying the hazard assessment is based on done by using volcanic hazard maps. Volcanic hazard map implying analyzing the hazard based on the past eruption history and the volcanic products in the area. There are different forms of volcanic hazard maps. Geology-based hazard map done based on the different products distributed in the area. Different volcanic hazard studies use GIS in order to model the hazard map and spatial extent of different volcanic hazards, according to Felpeto. There was a study which was conducted at Mexico by Alcorn using GIS-based multi-criteria evaluation. In this study, the volcanic hazard assessment was done for both pyroclastic density current and ashfall hazard. Then he combined the hazard map with vulnerability in order to generate the risk map of the area. And there is also a study in Ethiopia conducted at Aluto volcano by Mengistu using GIS-based multi-criteria evaluation. So the possible explosive eruption type and hazards from Fantale include pyroclastic flow and fall deposits accompanying dome collapse, ignimbrite forming eruption, volcanian or Pelian and Subplinian eruption, accompanying pyroclastic flow and pyroclastic fall, phreatic magmatic eruption, and partially explosive strombolian type of eruption. So the result shows pyroclastic flow is projected to be higher. It will destruct any buildings in the area, especially in the Matahara and different localities. It will scorch Awash Melka farmland and Matahara sugar plantation. It will kill biome and wildlife present in Awash National Park. It will also trigger a mudslide when it mixes with Awash River. Then another one is ashfall hazard. It will cause health issues. It will also cause respiratory related problems for human beings, and it will also disrupt different infrastructures in the area. Then the lava flow hazard will provide a modest risk as compared to that one. The main two towns, Matahara, Addis Katama, Lake Basaka, Awash National Park, and other neighboring localities are more vulnerable for the three hazard types in the area. Conclusion and recommendation: Fantale is a stratovolcano which has developed a shallow magma chamber inside, having both explosive and diffusive eruption products. Remote sensing and GIS are used as a good tool to assess volcanic hazard and risk of the area. So the hazard assessment done for the three hazard types such as pyroclastic, lava flow, and ashfall. The pyroclastic flow will cause a very high risk as compared to lava flow and ashfall, and it will cause different impacts on different exposures, followed by ashfall and lava flow. Recommendations: the area is geologically active and it is surrounded by different economic activities. So there should be a continuous volcano monitoring in the area. There should be also different investigations associated with geologic and geophysical approaches to reduce the risk from future eruption of Fantale. There must be a detailed hazard assessment to measure the magnitude, the future magnitude of eruption in the area, and the federal and regional governments should collaborate to do on early warning system and hazard management. I would like to thank my supervisors, Professor Gazany and Dr. Binyam, Addis Ababa University, School of Earth Science, Regional Center for Mapping of Resource for Development, RCM Maridi, and James, people surrounding the study area, and my parents. Thank you.
Thank you, Rahel, for your presentation. Questions?
Thank you, Rahel, for this wonderful presentation. It's not a common thing to see young youth already talking passionately about volcanoes. I have 2 points on which I would like to seek some more clarification. One, about the sources of your data. You mentioned that you got population data from DivaGIS, right? Yeah, population, DivaGIS. I was wondering, doesn't Ethiopian government hold censuses, like official demographic data, instead of getting such data online? That's one point. Another point is you mentioned in the beginning AHP, analytical hierarchy process, that you used it. I understand that this is a technique used in multi-criteria evaluation studies to assign weights to factors. If I recall well, you didn't elaborate more on that, how you used that in your study. Can you elucidate how you used this technique in your study? Thank you.
Okay, thank you. I was got population data from other source, but It was not full. It's not. It was not detailed. So I am forced to download from DivaGIS. That's why. And the second, I don't understand the second question. Repeat. The second question.
Oh, the second question was about AHP. How did you use that technique in your study? You didn't elaborate
Okay.
on that.
Analytic hierarchy process, or AHP, was done for evaluating the factors of lava flow hazard, which facilitate lava flow. For example, fault, elevation, slope are parameters which facilitate the lava flow hazard. The fault allows the entrance of the lava. So I give a weight for them based on their contribution. For example, for vent and caldera, I gave a higher weight because both allow the entrance of the lava, then followed by fault, elevation, and slope. And instead of risk assessment, I weight the factors based on their contribution as the same as for lava flow, as I do for lava flow, and I give a weight for hazard, a high weight for hazard, followed by population, because based on their importance, followed by land cover and localities and different facilities. Okay.
Okay, mine is not a question. I want to add on the first question regarding the population density data. So I think you want a raster data for your study, right? So as I work for the Central Statistical Agency of Ethiopia, so the data we have is not a raster one. So it will not help you here. So it's just a number. And so for mapping purpose, you need a raster one. And that's, I think, why you downloaded from DivaGIS. Yeah, thank you very much.
Thank you, Noe.
Yes, okay, a question. Did you look at the teleconnection between, of course, the volcanic activities and other earth movement processes that might influence or increase the frequency of these volcanic activities perhaps in future?
What?
Like the teleconnection of the volcanic activities and other parts of like earth movement. We have the earthquakes. At times they can also cause earthquake, and maybe we know if in future will the frequency of that volcano continuing erupting, or it will decrease and maybe finally become dormant.
Okay, thank you. As I said, there are different geothermal features which are a sign of volcanic unrest, or which shows there will be an eruption for the future inside the caldera and outside the caldera. Specifically, they are found at southern northwestern part of the Fentale caldera. So they shows there will be an eruption for the future. And there are different rupture surface or fissural structures in the state area. So they shows the area is volcanically active. Do you get my idea? Okay.
Okay, I think that summarizes the questions from the audience. Thank you, Rahel, for your presentation. Then we go to the last presentation, which is from Tsan. And she's looking at evaluation of spectral built-up indices for impervious surface extraction using Sentinel-2 imagery.
Hello everyone. I'm Tseun Ayalio from Addis Ababa University. School of Civil and Environmental Engineering, Geomatics and Geodesy Department. And my research title is Evaluation of Spectral Built-up Indices for Impervious Surface Extraction using Sentinel-2A MSI Measures, a case of Addis Ababa City. Here is the outline of my research. It includes introduction, statement of the problem, general objective, specific objective, description of the study area, data and data source, softwares and instruments, research design methods, and results, and finally the discussion. After the discussion, conclusion and recommendation. Here is an introduction. As my study is capital of Ethiopia, which is the urban area, I describe urban ecosystem. Urban ecosystems are comprising of heterogeneous land covers. It includes impervious surface, water body, bare land, forest, and others land use land covers. So my study or my research is focused on impervious surface. So I will describe the impervious surface. Impervious surface is anthropogenic features which water cannot infiltrate to reach the soil, which includes concrete building, roads, parking lots, and others. So to extract this impervious surface or built-up area, there are so many methods. For example, ground measurements and remote sensing. So ground measurement is a tedious method. So this research is focused on remote sensing, which is a non-destructive approach to quantify and characterize this built-up area. So in comparison with non-measurement, ground measurement, remote sensing is a more good approach due to the non-destructive technique. So remote sensing can be categorized for the extraction of built-up area into three basic main groups. The first one is spectral unmixing analysis, machine learning algorithm, and direct segmentation of the imagery through spectral built-up indices. So in these methods are designed based on spectral bands, which is the highest and the lowest of specific land cover classes. So spectral discrimination in the spectral indices technique have shown some remarkable approaches because of easy of implementation, less execution time, memory efficient, simplicity, and independency with training samples. So the statement of this, the problem is there is a large similarity between these land covers or the heterogeneous area due to their spatial, spectral, and temporal variability. Hence, the precise extraction of this magnitude ratio geometry of impervious surface is not a straightforward task due to the heterogeneity of land covers in urban area. So there are a number of approaches. The first one is spectral unmixing analysis. This approach is difficult to identify the pure or the most representative end members in extraction of built-up area. And the second one is a machine learning algorithm. This machine learning algorithm is an approach which is used directly by training samples. This training samples is affected by the location, size, and the representatives of the training samples. So I select the spectral indices, which is up to performed by their simplicity, rapidity of calculation, reduction of processing time, and high applicability. So there are a number of spectral built-up indices. However, in my study area, there is no evaluation of these various spectral built-up indices by using high-resolution Sentinel image in Addis Ababa city. So my research objective is, the general objective of this study is evaluation of spectral built-up indices for impervious surface extraction by using Sentinel images, a case of Addis Ababa city, Ethiopia. The specific objective of this research is to show the spectral response curve in between various types of spectral built-up indices, to evaluate various types of spectral built-up indices effectiveness for impervious surface extraction, and to identify the changes in land use land cover for 2060, 2080, and 2020 using Sentinel image. Here is a description of study area. As you see in the figure, here is Sentinel images for Addis Ababa city. Addis Ababa city is the capital of Ethiopia and located in the central part of the country, which is geographically located in 9 degrees 01 minutes latitude and 38 degree 44 minutes longitude, and have 539.1 square kilometers. Here is the topography of Addis Ababa city. The minimum elevation is 2,044 meters, which is the minimum one, and 3,030 meters, which is the maximum elevation of Addis Ababa city. And here is data and data source, which is used in my research. The first one is Sentinel 2A multispectral image, which is for 2060, 2080, and 2020 with a 10-meter resolution, which is used for indices calculation and other analysis. Aerial photograph, which is for 2020 with a 0.3 resolution for accuracy assessment. Ground truth data also used for accuracy assessment on also Addis Ababa city boundary to extract my study area. ALOS data for to identify study area topography, which is from Alaska satellites, and also population data, temperature, and rainfall data also used in my study. Software and instruments. The first one is Quantum GIS, which is used for pre-processing Sentinel images and also for spectral built-up indices calculation, and also to generate different thematic maps. NV, ArcMap, Google Earth Pro, and others also used in my researches. And also from the instrument handheld GPS is used in my researches to collect the sample point for accuracy assessment. Here is a methodology flowchart. I will continue. Image acquisition. The first methodology is image acquisition and pre-processing. The Sentinel image is first captured in level 1C, which is a cloudless Sentinel image, and it's used for spectral built-up indices calculation. This image is selected because of the first one is its relatively 10-meter resolution, which is high resolution compared to the free data, which is we captured freely. And the second is its radiometry. It includes 2 near-infrared and 2 short-wave infrared bands, which is highly used in spectral calculation. And after the image acquisition, atmospheric correction were held. Level 1C data have been processed into level 2A to remove aerosols and water vapors for image analysis, which is conducted by using QGIS within semi-automatic plugin, which realize only 10 bands for land use, land cover, and spectral built-up indices calculation. And after geometry correction, European Space Agency provides geometrically corrected Sentinel images in WGS 8490, WGS 84, UTM 37 North. After checking the geometry, I resemble the Sentinel-2 images. They have different spatial resolution, 10 meters, 20 meters, and 60 meters. So it should have been integrated. So to integrate this different resolution, I use nearest neighbor resolution approaches. So this 10 meter, 20-meter resolution. Bands were downscaling to 10-meter resolution. Then after spectral built-up indices were computed, the first one is urban index. Urban index first proposed by Kwamura in 1996, which is include the first band of shortwave infrared and the near bands. The second indices is normalized difference built-up index, which is proposed by Jean in 2003, and it incorporates the second band of shortwave infrared and near infrared. The third one is new built-up indices, which is developed by Jalil in 2008, which incorporates the red bands and the second bands of shortwave infrared in sentinel image. The fourth one is band ratio for built-up area. This index is developed by Walker in 2012, which incorporates the red bands and second band of shortwave infrared. And the fifth one is normalized built-up area indices. It incorporates the first and the second bands of shortwave infrared, and also from the visible bands, it uses green bands. And the sixth one is modified built-up indices. These indices use the first band of shortwave infrared, the red bands, and near infrared. And after the indices calculation, I compute the image classification. Image classification is a classification or the process which is conveying pixels into predefined land use land cover classes. So in my study, I used a machine learning algorithm which is support vector machine to classify these land use land covers into 5 major categories. The first one is built up, bare land, vegetation, forest, and water bodies based on LATAM in 2002. Urban land use land cover classification is, as I thought, based on support vector machine. This vector machine is based on machine learning algorithm. It uses or it separates a data set into different classes based on decision boundaries or hyperplane to reduce misclassification or unseen data. So this machine learning algorithm uses a region of interest, which is used as a spectral signature to classify 5 land use land cover classes. So after the classification, the change land use land cover detection were held for 2060, 2080, and 2020 based on this formula. For spectral built-up indices separation, I used the evaluation for spectral discrimination index, which is one of the evaluation approaches to identify built-up and non-built-up areas. This spectral discrimination index is based on the mean and the standard deviation of the two value, which is the difference of this mean and standard deviation of the value. So if the value is larger than 1, that means it separates well. Otherwise, this built-up and non-built-up area is not separated. After a spectral discrimination index or the evaluation, I check the accuracy assessment by using user accuracy, producer accuracy, overall accuracy, and kappa statistics. For accuracy assessment, 50 points per class were collected. Totally 250 points were collected for each land use land cover classes, and 200 sample points were collected for built-up and non-built-up land use land cover for each spectral built-up indices. Here is results for spectral built-up indices. The first one is built-up area extraction indices. As you see in the figures, 0.31 in 2060 is the minimum value, and 11.8 in 2020, which is the highest value for built-up area extraction indices. And the second one is band ratio for built-up area, which is 0.03 for 2060 and 4.6 for 2080, as you see in the image. And The red one is the high value and the green one is the low value. That means the high value, which is highly built up area, and the low value is non-built up area. And the third one is modified built up indices, and it's minus 4.18 for 1060 and 2 in 2020, which is the highest value. And for the fourth indices, normalized built up area indices, it have minus 0.47 in 2060 and 0.45 in 2020, which is the highest value. And the fifth one is new built up indices, which have 1.16 in 2020 and 0.01, which is the lowest value for the 3 years. It's the same in 2060, 2080, and 2020. And the sixth indices is a normalized difference built up indices, which have 0.73 in 2060 and minus 0.78 in 2060, which is similar years, which is the highest and the lowest value. And the final one is urban indices, which have 0.69 in 2080 and minus 0.57 in 2080, which is at the lowest value. So here is the results of 7 spectral built-up indices. The red one shows the highest built-up area, or it covers built-up area highly, and the green one is the lowest value, which is mostly non-built-up area. .2% and 0.7%. However, the other forest and vegetation were decreases by 10.4 and 31.1%. This implies that the built-up area is increased time to time. So this is results which is conducted by using vector machine algorithm. And also this is evaluation, my second objective, evaluation of spectral built-up indices. This is computed by using 2 shortwave infrareds, which is the first and the second shortwave infrareds. And I select from the near band, which is the narrow and the wide one. I selected the wide near infrared bands because it covers different spectral reflectances. So band 80 is intended for producing the spectral profiles of these land use land covers. So the first comparison based on built-up indices. As you see, this is the cropped maps from Sentinel-2 images for different spectral built-up indices. So from the results, normalized built-up area indices gives a very good results compared to the others. So the second one is normalized different built-up indices and new built-up indices scores respectively. So, however, the others indices like built-up area extraction index and band ratio for built-up area indices show unsatisfactory results due to the combination or the heterogeneous of urban area. This is the area that's computed from different spectral built-up indices. As you see in the from 2060 to 2020, there is a rising of built-up area from 52.8% to 56% for normalized built-up area indices, 40% to 44% for new built-up area, and 57.4% to 60.8% for normalized difference built-up indices. Here is the comparison based on spectral discrimination indices. As I said before, if it is scores above 1, that means a very good separation between built-up and non-built-up area. Otherwise, it's not separated, or it's not separated built-up area from non-built-up area. So from these results, the three indices, which is new normalized built-up area indices, new built-up indices, and normalized difference built-up indices, scores above 1. That means a good separation between built-up and non-built-up area. This is the third evaluation approach, which is based on histogram overlap. The histogram of these indices are computed by using NV software, by taking pixel numbers from each spectral built-up indices maps. As you see the table, this is a threshold value for each spectral built-up indices from 1060 to 2020. And here is a histogram of built-up and non-built-up land covers for 2020. The red one is a built-up land covers, and the blue one is a non-built-up area. And the points which separates the built-up and non-built-up area use as a threshold value to separate these two land covers. And the discussion part, employing the feature extraction approach into index methods may further to reduce the spectral similarity in between heterogeneous urban area in impervious surface and others. So the main argument is for using two near-infrared and short-wave infrared is it have built-up area have higher reflectance in these near wide and SWIR bands. So based on this, normalized built-up area indices have superior to other indices because it uses short-wave infrared to short-wave infrared. That means the first and the second band of short-wave infrared. So it achieves good results than other indices. And also, this result is confirmed by evaluating spectral differences corresponding to the histogram. So this method also promotes essential process in the context of analysis, which is conducted before, and also built-up area expansion. As built-up area expand, the other lands are diminished or shrink. For example, the built-up areas expand from 18 to 8,101.88 hectare to 27,186.737 hectare from 2060 to 2020. This implies that there is a high expansion of built-up area from 2060 to 2020. This also supported by different researches that's conducted in Addis Ababa city. Additionally, the results of spectral built-up indices also consists with the finding of the built-up area expansion. And here is a conclusion. According to the outcome, three indices, that means normalized built-up area index, new built-up indices, and normalized difference built-up indices, show a remarkable or a robust method that is capable to classify the built-up area and non-built-up area. And also it shows the changes that's from 1060 to 2020. And also it concludes that there is a high expansion or significant expansion for built-up area in these 3 years. And also the evaluation of these built-up indices show a substantial agreement with the spectral discrimination index, histogram overlap, and quantitative assessment. So these results show remarkable, or the indices methods are fast, easy, and more effective in built-up area mapping. Because of it utilizes the first and the second band of shortwave infrared, which is highly reflectance for a built-up area. And I recommended for the next or the future for also urban planners and government office to select their methods which is the fastest and also easy for computation in high resolution satellite images. These indices are the most robust and highly recommended in urban planning and governmental office. So in order to maintain a good results, another high resolution satellite image which is higher than 10 meter resolution, which is high resolution satellite images recommended to get or to maintain high accurate maps. And also there are other threshold algorithms like threshold algorithm, which will be checked. If it is checked for another or for the future, it may attain a good result. So here is my presentation. Thank you for listening.
Thank you very much, Sion. Do we have questions from the audience? Okay. Do we have any questions from the online? It's a combination. Okay. So thank you very much, Zion, for your presentation. I think you can take your seat. Then we'll run through some of the questions that are specific to the previous presenters. My suggestion is that we use less than 5 minutes for these questions, right? So, Professor Wambende says, thank you for your good work that has characterized the spatial and the temporal distribution of aerosols. My question is, what are the basic characteristics of the hotspot area? What should be done to mitigate the impact? And that goes to Christine. Okay. Still on Christine, Edwin asks, how is the ground data collected? Ahmed asks, what prompted the presenter to only settle for 4 weather elements? Rainfall was not supposed to be part of the list. Abeka Keide says, I would like to inquire where and how the ground-based data can be obtained. And do we have data concerning specific air pollutants like dust in Uganda?
Okay.
Do we still have that? So those were questions to Christine. Should I read all through, then they answer at once? So Christine should answer, I think.
Yes. Let's scroll back to the first one. The characteristics of the hotspot areas, it depends on the anthropogenic activities that take place in that area. So it is what the population carries out, or the economic activities in the area that determine whether it will be a hotspot area or a cold spot area. So the activities that are carried out in the area is what characterizes what the hotspot area will be. And then the second one, how is the ground data collected? Like I said at the start of the presentation, in Kampala, we have a number of ground monitoring stations that have been established, and these stations record PM10, PM2.5 measurements every 90 seconds. But this data can be aggregated to a resolution of 1 hour. So there are stations within Kampala that measure these pollutants on a daily basis. And from Kalumba, why rainfall was not part of the list is because the images that I selected were on the rain-free days. So the rainfall recorded on those days was 0. So that's why I did not take it as part of the weather elements that were used. And then Abe Kakeire, I think I've answered already his first question about how the ground measurements are obtained. And then the second one, do we have data concerning specific, okay, so dust is part of the particulate matter. So the sizes of the dust that is recorded is what will determine whether it will belong to PM10 or PM2.5. So it will be dependent on the particle sizes, but dust is part of the particulate matter air pollutant.
Great, and then we have comments to Faustin. Still, Professor Wambende says that we expected to see the different land units with different levels of the expected total soil loss in the Yanze catchment, which we did not see. How do we prioritize conservation if we do not have the total soil loss of the various units?
Yes, we have the loss, the soil erosion risk profile map for the study area, which was developed using the RASO model. I didn't give the figures during the presentation, but in my report they are. Point is, the main point of the study was not to estimate soil erosion. Soil erosion estimation was done in order to see that can be predicted using hypsometric analysis. So yes, we have those figures, but they were not the main objective of the study.
Great, and then questions to Neiwe. Tadeli asks, why are both Landsat 7 and Landsat 8 used in this study? Number 2, how does MODIS with 1 kilometer resolution help to validate Landsat data values which have a high resolution comparatively? Nare Josephine asks, I would like to further understand how you obtain the conversion matrix.
Okay, for the first one, it says why are both Landsat 7 and Landsat 8 used in this study. So for this study, to retrieve land surface temperature, I applied mono-window algorithm. So because of the temporal extent of the study, so the study year starts from 2006. So in that specific year, there is no Landsat 8. So I have to use Landsat 7 ATM plus thermal 6 pan for the purpose of land surface temperature retrieval. And for the MODIS, yeah, it's true, it's 1 kilometer, and for the Landsat thermal band, it's 13. So for the purpose of validation, the land surface temperature with 30 meter resolution is resampled to 1 kilometer to match with the MODIS 1 kilometer for the purpose of validation. So the solution is resampling. I already resampled it. So for the conversion matrix, this one is I did it in using ArcGIS in the GIS environment. Maybe I will share him the link and also the details from my research. It's already defended, and so it's well described in my research. You can also find on the website of Addis Ababa University just by typing my name. It's already there on the website. Thank you very much.
Good. And finally to Rahel, Professor Wambende asks, volcanic activities vary, therefore their risk vary in spatial terms. Therefore, I expect the risk assessment maps should be different.
Okay, thank you. The risk assessment map shows the pyroclastic flow hazard have more impacts on different exposure. Maybe the slide or the color difference maybe get confused, but there is a variation. There is a big difference between pyroclastic flow, ashfall, and lava flow hazard. Pyroclastic flow is more fast and it covers large area, so it is it have more risk than the lava flow because the lavas in the area are more viscous, so they cannot move long distance. So the pyroclastic flow is the higher risk hazard. Thank you.
Fantastic. So from AGRC and from my own behalf, I would wish to extend my thanks to Paul, to Christine, to Faustine, to Lynn, to Leiwei, to Clinton, to Rahel, and to Cyan. And special thanks to our online audience and the people that made it here physically. It's a thank you from us to you. Thank you.
Okay, thank you very much. And we come to the close of the first day's session. And I would really like to appreciate the resilience you've had to stay this long. And as New has said, especially to our colleagues from Ethiopia, I would like to express my congratulations. Apparently they are graduating on Saturday. So unfortunately, they will not be with us tomorrow. So congratulations and safe journey back. And our thoughts and prayers are with Ayele. And we hope and wish him a quick recovery. With those few words, I would like to bring this meeting to an end. We shall begin tomorrow at 9 a.m. So let's try to keep time so that we can go through the proceedings in good time. We shall start with an online session. So let's tune in, let's log in, let's come and let's listen to the excellent presentations that have been lined up for you. So have a good night, safe journey back, and there's a cup of tea. Please let's make time to enjoy it before we run off, or else I will have to drink all that tea. So have a good evening, and yeah, safe journey back.